Good day, students. We are now in the topic 2 of our lesson 4, and this is the part 4 of our video. So in topic 2, we discuss our topic 2 is the use of Matlab tool to solve transfer function. So I will teach you the basic transfer function, Matlab programming. So let's have this transfer function. G is equal to 1 over s squared plus 3s plus 2. Now this transfer function will give us a graphical representation of the response output of a certain system. So using Matlab, we're going to graph the response output. So let me share to you my Matlab screen. Now, when you're going to open your Matlab in your personal computer or your laptop, this will be the screen display of your Matlab. Okay? So, of course, dito sa taas, okay, I'm trying to zoom in. Okay. These are the commands in the Matlab. Okay, the home, the plots, applications. We're now in the editor. So this is the editor window. This one. Okay, wherein we edit here the Matlab program. Okay, for convenience, because you could directly write your command in the command window. Yun nga lang, once you enter a command, it will automatically display the result or the answer or the computation. Say, for example, if we're going to enter, say, x, let's enter an equation, x is equals to 3 times 5, that will give us an answer of 15, no? So you could, in the command window, you could directly write a command and it will automatically give you an answer. But that will not be convenient if you're going to write a lengthy or long command, no? So, para tuloy-tuloy yung pag-program mo, you will use the editor. Okay? Now, as I try to use the cell phone application of Matlab, I don't see in an editor window there. No? Ang meron lang doon is yung command window. So, pwede rin naman, kaya lang hindi siya ganun ka-convenient na direct kang naglalagay sa command window. But ang very challenge sa lesson natin is walang control system toolbox yung Matlab mobile. Kaya hindi natin magagamit. Okay, let me clear the command window. Now, let me see if I could zoom in my screen. Because if you are using your cell phone, maaring maliit. Anyway, see here. Now, in this command editor, we use this symbol, the % symbol, okay? if we want to write comments, okay, anything without the percent symbol will be the command line or mismo yung syntax or mismo yung function or operation, command operation. Like in line number 7, okay, we don't have the percent symbol here. So we are already writing a program dito sa portion na ito. So in line 7, this is num equal to bracket 0, comma 0, 1 bracket, and then semicolon. Now, anong ibig sabihin nito? We are defining the numerator coefficients, or technically, they are called vectors. Please take note that our transfer function equation is this. So G is equals to 1 over S squared plus 3S plus 2. So in our numerator, we have coefficient of 1, okay, for the first term. We don't have second term with S sa numerator, and we don't have the third term na S squared sa numerator. That's why we have 0, 0, 1. Okay? In the denominator, we have coefficient of 1 in the term S squared. So we have 1 here. We have 3 for the second term. That's why we have here 3. And we have coefficient 2 for this term. So that's why we have here 2. So they should be written in that proper order. Okay? Or else mag-iiba yun. So for this line 8, we defined the denominator coefficients of our transfer function. For line 9, this one, we define the G to be the transfer function of the numerator and denominator. And the syntax is written as EF, parentheses, num, comma, then, parentheses, and semicolon. Okay? And then in line 10, we define the Y output response using step command. So it is written bracket Y, comma, T, close bracket equal to step, and then parentheses are G function, comma, 10, close parentheses, semicolon. So this G is the equivalent value of our G that we have defined here as the transfer function of the numerator and denominator. So whatever is the value, it will be given here. Okay? And 10 here specifies the number of time frame that we want to specify, no? For a given values of our time. Okay, diba we have discussed that the transfer function is in S domain of the equivalent differential equation in the time domain. So in this case, we are defining our graph in the time domain, and 10 is the unit of time steps. Okay? And then in line 11, we're going to plot our graph of the transfer function. So plot of Y output versus time t response graph. So the syntax is written as plot, parentheses, the t for the time, comma, y, comma, g, our transfer function. So take note that there is an apostrophe g, apostrophe, meaning to say, yung ipa-plot niya is yung value ng g ng transfer function. Okay? And then from this, we're going to run our program to test it. So at the same time, you save for this function or operation saves our program, and then it runs our program. So let me press this now. Okay. So notice that when we run our program, it plotted the graph and it gives the some details that I will explain later. Now, let me share to you, let me share my screen about the graph. Okay, so that is now the step response output of the graph of our transfer function. Okay, now let me go back to my screen in Matlab window. Okay. Now notice that we have optional displays. Huh? So you notice in the graph that we have a step response. Okay, let me edit that. Okay, so doon sa title, no, sa upper portion of the graph, may nakasulat doon na step response. And then sa bottom of the graph, may nakasulat na time. And then sa y-axis or sa vertical, may naka-label na amplitude. Now, the step info command, this one, step info y of t, okay, if you want to solve an additional information about our transfer function graph or response graph. So, in this command window, okay, this is the step info output. Okay, so we have here the rise time, the settling time of the graph, the settling minimum of the graph, and the settling maximum of the graph, the overshoot, the undershoot, the peak, and the peak time. Okay, so for now, hindi nyo pa alam kung anong ibig sabihin yan, pero sinabay na natin dito, no, kung paano ito i-command sa Matlab, because on our next topics or lessons, we're going to explain the meaning of this details of the graph. Okay? So once more, for our transfer function equal to 1 over s squared plus 3s plus 2, the response graph will be this one. Okay, so that's the step response graph. So notice the amplitude, no, the time label, and this is the set value 0 to 10. Okay, so let's end our presentation for now, and we will continue in part 5. once more, students. So we are now in the lesson 4, part 5 of our video presentation. I have included in the PowerPoint the screenshot of the Matlab uh, window so that you could see better. Because kanina nga, maliit no, ang font dahil full screen no, ng laptop ang nakikita ninyo. So this is much better, I believe. Okay, so this is the MATLAB script or program that I've been discussing to you in part 4 of our video presentation. Okay, and I would like to add that this semicolon no, is provided so that we don't want to show the computation of every line in the command window. So for example, in this line 7, if we're going to uh, delete this semicolon, and likewise in line 8, uh, it will be shown in the command window, the values of num and the values of gen. So then rather. So here it is. Okay. So in this case, the num and the den were shown, meaning tinanggal yung semicolon. I could demonstrate that to you later on. I also included here the screenshot as well of the output graph of our transfer function. So here's the step response, the title of the graph, the x label or labeled sa x-axis, and the amplitude is the label no, for the y-axis. Okay, so the 0 to 10, that is the indicated value that we put in our script, while the 0.5, it's the maximum peak of the transfer function no, being solved. So whatever is the solved value na peak value niya, so as you can see in the setting max, it's 0.5. So that's why nasa 0.5 yan. Okay, so let's now proceed to example 2. Okay, wherein I will show you another method, another way of MATLAB script for solving transfer function. So notice here that this time we define k variable to be the transfer function in the S domain. No? So it is written k is equals to tf parentheses apostrophe s parentheses close parentheses. Okay, and then for our transfer function, notice also that we really written the equation of the transfer function. No, if you recall kanina, no, sa example 1, we only defined g to be tf and then the num and the den. But this time, we define g, the equation itself, no, in the S domain. So notice that the syntax is just how we do. I think may mga yung advanced calculator sa ngayon, no, ganyan ang syntax, no. So 1 for the numerator divide by. So we need to enclose the whole denominator in a parenthesis, okay, and we have to put a numeric coefficient 1, no? 1 times the s squared. No? Pag hindi natin kasi nilagyan ng 1, magkaka-error. And then plus the 3 times s, so hindi pwedeng 3s lang. Okay? And then plus 2. Okay? So the rest are just the same. Now, I want you to notice also here that the step info command, wala siyang semicolon. That's why in the command window, na ipakita, no? Values ng step info. Okay? So these are the values of the step info. This time, if you notice, wala yung num at saka yung then kasi may semicolon. No? Okay, and notice also that this time I included the grades. No? Kanina sa graph natin kanina walang grades. Pero dito, meron ng grades, no? Para mas madaling mag-analyze. So kung titingnan natin, the rise time of 2.58, okay? So that's from 0 to 2.5 somewhere here, no? So that's the rise time. No? May topic tayo about that later. I will explain these things, no? But just to give a bird's eye view, no? So the settling max, or tinatawag natin itong tawag dito yung ating state space, or rather this is the part of our transfer, our transfer response, and then our steady state response. Okay, yun yung settling max natin, no? Nag-settle siya sa 0.5, no? So that's the steady state response, while this portion is the transient response. Okay. Sige. So this time, let me share to you my screen in Matlab. Okay. So I hope you're seeing now, no, my screen in Matlab again. So that we could view the whole editor window, let me minimize the command window. Yan. Okay, so I just minimize command window at nandito na siya sa side. Okay, kung gusto nating makita yung command window once more. So meanwhile, let's go back to the editor window. Okay. Ayan. So let me minimize that again. Okay, so this is the editor window. At ito na yung nakita nyo kanina, no, sa PowerPoint natin para mas malaki. Okay, now let me demonstrate to you if I'm going to delete the semicolon here. So I will delete the semicolon in every line, and so that I could show you kung ano yung effect niya. Now, dito sa plot, hindi talaga makikita sa plot yung command window. Sa command window yung plot kasi talagang different ano siya, no? Window, yung plotting. Also the grid, the title, the labels, no? So sa ibang window sila na-graph kaya hindi sila makikita sa command window. Now let me now press the run button again, this one. Okay. So when we press this once more, it will automatically save. No, kung ano yung na-edit natin, it will save and then it will run the program. So let's do that. Okay. So let me show you the command window now. Okay. So we are now in the command window. No, this is now the result, no, or the output of the computation. Let me scroll up. Okay, I'm scrolling up so that I could show you, I could explain to you what happened, no, nung tinanggal natin yung semicolon. Okay. So, dun sa unang line ng command, we defined K. So that's why K is now equals to S, no, a continuous time transfer function. And then we also define G. So eto pinakita niya yung G, no, to be this equation, which is also a continuous time transfer function. And then the next line is, if you recall, we have defined the y and the t, no, as a step function of the g in 10, a value of time which is equal to 10. So it generated the value of the y starting from 0 with increments of these values, no, in decimal, no, so talagang for accuracy. Okay? Kaya ayan, yan yung mga values ng y. Okay? Uh, so it is of course increasing. So if you could imagine now, yung ating graph kanina, these increasing values of y, no, say 0.2805, 0.891, 0.2973, 0.3, pa-increase hanggang sa 0.37, hanggang naging 0.4, at mag-end yan sa tingin nyo sa anong value? Yung peak value, which is 0.5. Okay, let me continue scrolling down. Okay, scrolling down. So, although the value of the time is we set to 10, that 10 is divided into small values up to 4 decimal places para mas accurate na yung graphing. So here, no? So the maximum value here is 0.5. Doon sa ating settling maximum, di ba? So 0.5 ang na-compute niya. So ito yung value ng time. And then for the ng y rather, the amplitude y. At ito naman yung value ng time t. Okay, of course, it's also started from 0 at 4 decimal places na rin. For accuracy, of course, it will increment. Ayan, let's scroll down. Sa tingin nyo, it will increment to what value? Okay, nasa 1.9, 2.0, until 2.9, then 3.0. Okay, so I hope you notice the values. Mag-increase yan up to 10, no? Kasi we set it to a maximum value of 10. So, the value of y and the value of t are paired values, no? Sa inyong geometry, if you remember, if you have xy value, paired value, so you could plot the point of an xy point, no? This time we use y. Okay? So you see, the maximum value of RT is 10. And next na binigay dito sa ating command value is the step info command details. Okay? And once more, let me share to you my screen doon sa output graph natin. Okay, so eto na siya. No? So this time, yun nga, meron na siyang grid. And yung nakita niyong values of y kanina, it's from 0, no? Nag-i-increment siya up, by 4 decimal places values until ma-reach niya yung 0.5. Okay? And then sa time t naman, from 0 up to 10, and then nag-i-increment din siya ng 4 decimal places, no? Para talagang accurate. Okay? So, yan yung ating graph. So, this is the step response of our transfer function. Okay? So, this is the basic example. This is, we will now end our video presentation for part 5, and we will continue to part 6, wherein we're going to discuss our example transfer functions in our PowerPoint lesson. So once more, students, good day. And we are now in the lesson 4, part 6 of our video presentation. And I believe this will be our last uh, part, no, of our video presentation. Now, in this example, I want you to recall that in our discussion of the transfer function, I have given you an example circuit of an RLC circuit, this one, wherein we solve the transfer function equation. Andito siya sa baba. And para mapalakihan, ayan. No? So, ito yung transfer function of the RLC circuit na ating na-compute. I also want you to notice that the given values of the capacitance, which is equals to 2 farad, the resistance, which is 1 ohm, and then the inductance value, which is 3 Henry. So the combination of the values of the RLC affects the transfer function. That's why pag nagdi-design ka nga ng circuit o nag-analyze ka ng circuit, pag nag-iiba yung value ng mga components mo, you would also expect na mag-iiba rin yung transfer function niya at mag-iiba rin yung response ng circuit mo. Okay? So, with this transfer function, let's do Matlab simulation. So, I pasted here the editor window for better viewing. So this is the Matlab script or program for our transfer function S6s squared over 6s squared plus 2s plus 1. Now this time, please notice that since our numerator is only one term, but it's in the term of s squared, so that's why the 6 is nandito, no? And then wala siyang value ng s, kaya 0, at wala siyang value ng 1s, kaya 0 din. While sa denominator, we have here 6 for s squared, so 6 dito. And then numeric coefficient of 2 for the s, so 2 dito. And then 1 here. Okay, so we have here 1. Okay? By the way, I used the Matlab script na yung una, no? Yung may numerator and denominator. I intentionally omitted the semicolon here so that you would see, in the command window the result. The rest of the script are the same. Okay. So this will be the generated graph or step response of this transfer function. Okay. So once more, imagine that this is an RLC circuit. Okay. At ito yung magiging response ng kanyang output. Ano ba itong response na to? Remember, na ang transfer function na ito is V out over V in. Meaning, this output, okay, amplitude, that would be an indication of the V out. Okay, for every input that you're going to enter into that RLC circuit. Okay? And then, notice here that nanggaling siya sa 1, no? So, ibig sabihin, wala ka pang input, may output 1 agad. Okay? And then, the system it drops actually, it oscillates, okay, until it settles to 0. Okay? So, yung kanyang settling time is, steady state value is around the 0. Okay? So that is for our problem 5. Now let me share to you my screen in Matlab. So we could do the demonstration. So eto na nga yun, okay? So let me run this one. And let us see the command window. Ayan yung command window, no, na nakita natin doon sa PowerPoint na rin. And let me show you my screen for the graph. So here's our graph. Okay? Okay. Now, what I want you to notice here is the value 50 that we indicated, no, doon sa Matlab script natin. In our previous example, we use only 10. Okay? But notice here, kung 10, for example, ito lang, hanggang dito mo lang siya nilagay, hindi na natin makikita kung ano yung next. Okay? So, let me show you that. Let me share my screen again in Matlab editor window. Okay, let's go back to the editor. So, eto, no? Di ba sa previous example natin, we used 10. But this time, ginawa natin 50. Now, i-try lang natin yung 20, for example. What will happen? No? Okay, so let's run that one. And let's view the graph. So there goes our graph, no? So from 0 to 20 lang siya. And then, hindi natin nakikita dito kung saan siya nag-settle, no? Kasi ang nakikita lang natin na portion ng graph is yung varying or oscillating pa siya. Okay? So yun yung importance, no? Kung how, what would be the value of time that you're going to set in your program. Regarding the amplitude, it is automatically generated by the system depending kung ano yung na-compute ng system doon sa transfer function equation. Okay? Sige. Now, let us go back to our PowerPoint presentation. And we're going to proceed to our example problem number 7. Okay, this one. So this is our example problem for our complex circuit. Now, if you remember, yung page 5 problem, it's a simple circuit, RLC circuit. While this problem sa page 7, this is for a complex circuit with 2 loops, no? Mesh equations. Okay, so recall that there are 2 values of resistors, no? So R1, 2 ohms, R2, 2 ohms. The inductance is 3 Henry and the capacitance is 4 farad. If you have view my lesson 4 part 4 or rather part 3 video presentation, I gave the correction there, no, that the final answer of the transfer function is not 19s dito, but should be 16, no? Kasi it's 2 times 2, that's 4. 4 times 4, that's 16, no? So dapat 16, no, not 19. So dito sa transfer function na nilagay ko, yung corrected value na. So the transfer function for the complex circuit, no, 2 loops ay ganito, no? 3s over 48s squared plus 16s plus 2. By the way, I hope you've noticed why it is important, no, during tayo ay nag-simplify, no, dito sa portion na to. bakit pa kinakailangan pang i-manipulate, no? Bakit kinakailangan pang convert or i-manipulate yung final equation, final answer into this format, no? Bakit ba hindi hanggang dito na lang? No, bakit kinakailangan ilagay pa sa ganitong format? Kasi nga, when we do transfer function, especially in Matlab or in any software applications, it should follow, no, a standard format para mas madaling program. Anyway, this computation is hindi kasi naka-include agad yung values ng mga constant na resistor, inductor, at capacitor. Naka-symbol kasi siya. Pero kapag nagdi-derive ka, wherein alam mo na agad ang value ng inductor, resistor, capacitor, mas madali siyang i-manipulate. Okay? So let's now proceed to the Matlab script. I'm sorry, I've not included the Matlab script in my PowerPoint, but I will correct that. So let's just proceed to the Matlab screen editor. Okay, so let me press this one for our page 7. Okay, so here is the Matlab script for example problem at page 7. Ang nag-iba lang naman dito is itong value ng num at saka yung value ng denominator. And again, since this time our numerator is 3s, wala siyang s squared na term at wala siyang numeric na term, that's why nasa gitna yung ating numeric value 3. 0, 3, 0. And of course, for the denominator, we have 48, 16, 2. So, ayan. 48, 16, 2. Okay? So, the rest of the script is all the same. Okay? So, I also omitted the semicolon in the G so we could see it in the command window. Okay, so let me run. Okay, and then let's see the command window. So, ito siya. Okay, so here is the command window, the transfer function and the info, no, step info. Now, let me now share you the graph. Okay, so this is now the graph of a complex circuit with two mesh equations or two loops. Okay, so as you noticed again, it starts from 0 and then fluctuates upward up to 0.12 something, and then it goes down again and it settles at around 0 also. So that's how our circuit performs. Please note that as the value of RLC of the resistor, inductor, and capacitor changes, this graph will also change accordingly. So, meaning to say, iba-iba ang step response ng circuit nang iba-iba rin yung value ng kanyang components. That's why in making your project, you cannot simply change values, no? When you change value, you have to consider certain range kung saan ka pwedeng, up to what ka pwedeng mag-change ng value niya. Unless you really wanted na baguhin talaga ang kanyang performance, kanyang step response. For now, the objective of our study is just for us to learn how to use the Matlab tool in computing and graphing the Matlab equation. But at this point, hindi pa natin goal or kasama sa lesson natin how to interpret this graph. Okay? And in our future discussion, we are going to study that. Ano ba ang ibig sabihin ng mga graph na ito? Ng mga performance na ito, no? Aaralin natin. Okay? So for now, that ends our lesson in lesson 4, the transfer function in Matlab. So thank you, students, and have a good day.